So what I did is just kind of clean up this area around here so we have a little bit more room to work. So we know which way it opens. That box is really important because we're going to put lines through it. They should be dashed because they're asymptotes. It's going to come right through there, and this is going to help us bound our parabolas. So we got one line's coming through that way. We get another set of them right through the corners of that rectangle we made. Okay. Now, we start at the vertex, obviously, and I don't want any more exact points. Okay, you could, pick certain x values and find the corresponding y's just by plugging them in to your equation, but just have it go through the vertex. Make sure you have your focus labeled. Don't worry about the lattice rectum line in this case. Okay, that's enough to be bounded by these asymptotes like this. Now, you are going to be asked sometimes to come up with equations for these asymptote lines. They're actually not very difficult at all. We know how to do linear stuff. We need a slope, we need an intercept. So we know the intercept 0, 0. That's pretty easy. Just think about how you made your box. It's a 3x4 box on each to get to each edge. So there's your rise over run. So equation of the asymptote, up 3 over 4x, and then we had one in the other direction too. So we went down 3 and over 4. Now if that changes off of the origin, just simply do point slope. So you'll know the slope just from creating your box. There's your h value, there's your k value. Okay? So there's one where they give you some information and you guys have to get a picture and get the equation. There's also what it looks like, nice and neat, all done on a computer. Okay, everything all labeled for us exactly like we had. Here's another example. So we've looked at a few of these where we've had to complete the square. So find the center, transverse axis, so which axis is it open on, the vertices, foci, and asymptotes of this guy. So we look at it, we know both things are squared, so it could either be an ellipse or a hyperbola. You notice that one of them has a negative with it, so that's going to be your sign of hyperbola. So eventually I'm just going to give you something like this, and you got to figure out what it is. So it's nice in that all the x's are already grouped together for us. So we know we got to complete the square like this. All the y's are grouped for us, but here's the trick. Okay, it's as easy to do. You have to watch this negative when you complete the square. If we want a formula that's minus y squared, so you're pulling this negative out, okay, but we need to get to positive 8y. So you have to change the sign of that guy. That's going to be the easiest thing to forget. So once you get this all set up, make sure when you distribute this negative that you get the original that we wanted, in which case we do. So you're not just pulling that negative out, but it's going to affect some signs in the remainder of the parentheses. Swing this to the other side as we've done before. Now we complete our square. Half of 4 is 2, squared is 4, but we really didn't add 4, we added 16. Half of 8 is 4, squared is 16, but we didn't really add 16, we really subtracted 16. Now, use your favorite math F word, get this guy all factored out. Always half of b squared. Those actually cancel. It's not always the case though. So you get to here. You see the minus sign, so you know it's a hyperbola. You don't want that 4 in front, and you certainly don't want this thing equal to 16, because our equations always equal 1. So we've talked about not dividing by what you see in front of the x's and y's, but getting this thing equal to 1. So we do this. there's our equation for our hyperbola. So I transferred all that information over here to a graph so we can actually get a picture of it, and there's our equation again. So we look at it, the x squared is first, so I know it's going to open on the x-axis. So I know it's something like that, okay? I know the center is -2, 4, because we always take the x-coordinate first. Now, with hyperbolas, you do have to remember your a squared value always comes first. So that means a is a 2. That means this is your b squared, so b is a 4. So before I do anything else, I'm just going to plot what I have. Label that as your center. Now it is opening up on the x-axis, so when we have an a of 2, we're going to go this way to get a vertex. We're going to go 2 this way to get another vertex. So the foci have to be on the opposite sides of each of those. I know the b is 4, so I'm going to go up 4 from the center or from each of the vertices and create this little rectangle. Okay, so there's the box. Now let's get some foci for it. So we know hyperbolas follow a true a squared plus b squared equals c squared. So c squared equals 20. So I'm going to say c equals 2 square roots of 5. So to get my foci now, they need to go on the x-axis. So I'm going to take the x-coordinate of the center, and I'm going to add or subtract 2 square roots of 5 from it, and they're still going to be up 4. So everything can't be a nice clean number here. So the box was nice, that was neat, but you're going to have to get these foci. So literally just go to your calculator and figure this out. Okay, so we're going to plot one of them at 2.47 and the other one at -6.47. So basically 2.5 and -6.5. So call that one foci, and then we wanted to go -6.5. So call that another foci. Okay, take a ruler, put in your asymptotes. And then put in your parabola through your vertex bounded by these asymptotes. So this guy opens really, really wide. Okay, so we've listed our center, we've listed our foci. Okay, we can easily get our vertices, grab them off of here, and we got a nice clean picture with everything in there. Here's one done on the computer, okay, with some exact values in there. Those are the numbers we've seen before. Got all our vertices labeled. Equations of these asymptote lines. This is what I was talking about with using point slope. So we know the center is -2, 4. So there's your x-coordinate, there's your y-coordinate. Now to figure out the slope, just figure out what you did for your box. We went up 4 over 2. That's a slope of 2. So one of them is going to have slope of -2. One of them is going to have a slope of +2. And then you can easily turn those into mx plus b's. Okay, so look at those two examples. Think about questions you guys have, and we'll practice some of those in class tomorrow.